let us define Wmp spaces. Let's start with m, an integer, and p, a real number, in between 1 and plus infinity, and sometimes not a real number, simply infinity. Now, a subleft space, Wmp, will be defined as the set of all functions f that are in LP, such that the derivative with respect to the alpha multi-index is in LP with the multi-index, the absolute value, so to speak, of the multi-index smaller than m. And the distribution are useful here because what we're doing when we're talking about the derivatives is the derivative in the sense of distributions that we just defined in the previous video. We can also define a norm, and the norm of f, mp, will be the sum of all integrals of the derivatives of the derivatives of f raised to power p, and all of the sum will be raised to power 1 over p, which is the same as taking the pth root of this sum. This is a Banner space. Wmp with this norm is a Banner space. So that is actually pretty good news if you think about it. Now, fmp with 1 bar can also be defined, and that is a semi-norm. And remember, if you forgot what the semi-norm is, I suggest that you go back to the second week where we defined this. And this is simply the sum, not for all alpha smaller than m, but all alphas or absolute values of alpha equal to m. I'm going to give you an example. W23 of the interval 0, 1 is the set of all functions f that are in L3 because of the 3 which is here. So all the functions f that are in L3 of 0, 1, such that the derivative of f is in L3 and the second derivative of L is in L3. So the reason why I look at two derivatives is because of the 2 of the W23. The norm in W23 of f is the integral between 0 and 1 of the modulo of f cube plus the integral between 0 and 1 of its derivative raised to power 3 plus the integral between 0 and 1 of the second derivative of f raised to power 3, and I take all of this sum and raise it to power 1 over 3. Basically, I just take the cubic root of the sum. Now, function x gives x raised to power 3 halves, so that's x times square root of x, does not belong to W23 of 0, 1, and you can verify that you don't have the second derivative of this function in L3 of 0, 1. So it is not an element of W23. However, the function that associates x to x raised to power 9/5 does belong to W23 of 0, 1. And you can verify that the function is in L3. Its derivative, you can compute, is in L3. And the second derivative of this function is also in L3. So x gives x raised to power 9/5 happens to be a function of W23. If you look at W12 of R, then what you have is all of the functions f that are in L2 of R, such that the derivative is in L2 of R. And you can define the norm of f in W12 as the integral of the absolute value of f raised to power 2 plus the integral over R to negative infinity and plus infinity of the derivative of f raised to power 2, and the whole thing raised to power 1/2, so you take the square root of all of this. Now, what you have with this space W12 is something we will describe in more details in the next video.